Day 5, we'll be taking a look at graphing a linear inequality. So we have one task that we'll look at today, and then we'll practice the new material. So the first task is, when looking at the past season, Kelvin scored no more than 12 points a game. He scored 2 and 3-point shots. So this looks like a problem that we've done before. We know that if we want to write the inequality, we have to define our variables so we know what things stand for. So that's the first step. What should we call our x? What should we call our y? So I'm going to decide to call x the number of 2-point shots. And then we'll call y the number of 3-point shots. And so an inequality could look something like this. It's going to be 2 times every 2-point shot plus 3 for every 3-point shot. And he scored no more than 12 points a game. So this is what he scored right here. He can score less than or equal to 12 points. So there's the inequality that represents the situation right here. With your table, come up with 4 different combinations of 2-point and 3-point shots that would work. Write the combination as an ordered pair. So again, x is the number of 2-point shots, y is the number of 3-point shots. So here's an example. 1, 2 stands for 1 2-point shot and 2 3-point shots. And so we can figure out what that total is, and we want to see, is that number less than or equal to 12? So 1 times 2 is 2, 2 times 3 is 6, and we get 8. Is 8 less than or equal to 12? And it is. So we know that this would be a combination that would work for describing the number of points that Kelvin could score in a game. So we would write that as 1, 2, and it would work. So you could put it right here. Oops, not right there, right here where it says 4 combinations that work. So again, in class, you'll be testing different numbers. What are some other combinations of 2 and 3-point shots that will fit the situation that's less than or equal to 12? And then what are some examples of combinations that do not work? So I'll just put some up here. I know that 0, 0 will work because 0 times 2 plus 0 times 3 is 0, and that's less than or equal to 12, and he can score 0 points. We could do, let's try 3, 2. So 3 times 2 is 6. 2 times 3 is 6, and that's less than or equal to 12. So 3, 2 does work. We could do 4 2-point shots and 1 3-point shot. So again, let's just test it. We would do 4 times 2, which is 8, plus 3 times 1, which is 11, and 11 is less than or equal to 12. So here are 4 points that work, and we would graph it. So here's my color that works, and we would graph it right here. Okay, so hopefully you're able to get 4 points that work. Some points that don't work would be 1, 6 wouldn't work. Because 1 times 2 is 2, 3 times 6 is 18, and that's way bigger than 12, right? So we know that 1, 6 would not work. Negative numbers wouldn't work, right? So 0, -1 couldn't work because you can't score -1 3-point shots. So we know that wouldn't work. 4, 4 wouldn't work. That would be way too big. 0, 7 wouldn't work because 7 times 3 is 21, and that's way more than 12 points. Okay, so we have some points here that work and some points that don't work. So the question is, what's an easier way than just doing guess and check and plugging in points? What's an easier way to find all the different values that would work in this situation? And an easy way to look at it is if you graph this inequality right here, and the constraints, then we'll have an area that will show us, okay, where are all the points that work and all the points that don't work. So let's graph it. Let's graph Kelvin's inequality. Again, his inequality was 2x plus 3y is less than or equal to 12. To solve an inequality, it's like solving an equation. So you can draw your line down, and we want to get y by itself so we can graph it. We can see the slope and the y-intercept. So first step, subtract 2x from each side. We'll get 3y is less than or equal to 12 minus 2x. And then to get rid of the 3, we can divide each side by 3. And then I'll just simplify. So y is less than or equal to 12 divided by 3 is 4 minus 2/3 x. So it says to graph it, place a point at the y-intercept. So here, what's the y-intercept? What number is by itself? And that would be at 4. All right, so I'm going to graph this in purple. And then it says, from that point, use the slope to graph the next point. Our slope is negative 2/3. So if it's negative 2/3, we're going to go down 2 over 3, make a point, down 2 over 3, 1, 2, 1, 2, 3. And then we can draw our line. And it says testing points. Pick a point on your line. Does it work in the inequality? And we knew that the blue points worked, and this point is actually on the line right here that I tested. And so we do know that that point works. And that point was 1, 2, 3, 3, 2. But here's what they want you to do. They want you to plug it in and see if it works. And I'm just going to plug it into this main inequality right here. So 2x plus 3y is less than or equal to 12. So pick a point on our line. The point on our line was 3, 2. So let's plug that in for x and for y. So we'll have 2 times 3 plus 3 times 2. Is that less than or equal to 12? And again, I already tested it, so I know it works. But if I'm showing my work, that's 6 plus 6, which is less than or equal to 12. And that does work. Okay, so then it says pick a point that worked and plug it in your inequality. What do you notice? And again, we already picked one that worked in our inequality, and we can see that, okay, it's true. If the point works, it's true in the inequality. Pick a point that didn't work, plug it into your inequality. So like these red points didn't work. So for example, this point didn't work. That was 0, 7. And we saw that it didn't work in the inequality. So 0, 7, if we plug in, it would be 2 times 0 plus 3 times 7. And we have to check, is that less than or equal to 12? And we know that, hey, 3 times 7, that's 21. 21 is not less than or equal to 12, so that doesn't work. And it says for step 4, we need a way to show others where the regions where our points are true. And so in order to do that, we're going to shade in. So notice, if I shade this region right here, any point in this region works. We have 2 common sense constraints. We know that one of them is our x values have to be greater than or equal to 0. So here's where x is 0 right here, and it has to be greater than or equal to that. Also, y has to be greater than or equal to 0. So that kind of makes our boundary line for this shaded region where all the points work, right? So we have our inequality that we're going to graph. We have some common sense constraints right here, and we can see that any point within there that works in our inequalities is in this shaded region, and that means that's where all the answers are. So, I mean, that's the stuff for graphing inequalities, for finding all the points that work in an inequality without having to plug in and use like guess and check. So here are the steps. Get y by itself, which we did for the basketball problem. We solved for y to get a slope and a y-intercept. If y is already by itself, it saved us step 1. So then step 2 is identify the y-intercept and the slope, and we're going to graph it. So here the y-intercept is negative 6, because it's the number by itself when y is by itself. Our slope is 2, which is the same as 2 over 1. So it's positive. We're going to go up 2 over 1 and make a dot. You can do it a few times. Step 3, is your line solid or dashed? Is an answer true on the line? So if you notice, for the basketball problem, we wanted all the points were less than or equal to 12. And so if it can equal the number, to show that our answers can be on the line, it's going to be a solid line. If you have no inequality, so again, if a solid line is if you have an equal sign, because your answer can be on the line, it's going to be a dashed line if your answer has to be above or below the line. So your answers can't be on the line, you'll have a dashed line. So we'll do an example of that. But this one is, okay, so we're looking for where are all the y values bigger than 2x minus 6. So we're going to have a dashed line. And what that means is our answers are all going to be above that, and they can't be on the line. If it's solid, it means our answers can be on the line. So then this last point is pick a point and test and shade it to see where are the answers. We know the answers are going to be one side of this line. Where's y bigger than 2x minus 1? So you want to pick a point, test, and shade it. So the easiest point to pick, if your line is not on there, is 0, 0, because it's really easy to plug in 0, 0. So let's plug that in and just see, is the inequality true? So we're going to plug in a 0 for x and a 0 for y, is 0 bigger than 2 times 0 minus 6? So we're just going to test that and see if it's true. So we have is 0 bigger than, and 2 times 0 is 0, so minus 6. Is 0 bigger than negative 6? And that's true. So if it's true, you look for where your point is, and it's going to be true for all the points on that side of the line. So we're going to shade where it's true. So what that means is any point in the shaded region, whoops, my shaded region got too ambitious there. All right, so any point in the shaded region right here, if you plug any of these points into this inequality, it's going to work. If you plug any point below the shaded line where, well, if you plug it in, it's not going to work. It's going to be false. All right, so we pick a point, test, and shade. And then if it's true, we shade that side of the line. If that point had been false, we would have shaded the other side of the line, and we'll practice that more tomorrow. So if you take a look at your assignment, and again, it's can you figure out, does it work on that side or does it not work on that side? So you're just plugging in and testing, does it work? If it works on that side, you shade that side, and if it doesn't work, you don't shade that side. So you have one page to do for your assignment, page 17, and you're just testing to see, like, are these solutions true or are they false? And then tomorrow, we'll take a look at reviewing how to graph the inequalities.